Foundation and Base Overview. Hello everyone. Today we will learn about the concepts of foundations and base together. Let's first look at a case study. This is the Leaning Tower of Pisa in Italy, an 8-story building constructed between 1174 and 1350, entirely made of white marble. The total weight of the tower is 14,200 tons. At present, the settlement on the north side of the tower is about 90 centimeters, and the settlement on the south side is about 270 centimeters. The horizontal distance between the tower top and the vertical center line has exceeded 5 m, and continue to tilt at a rate of 0.2 millimeters per year. Why does the Leaning Tower of Pisa tilt so much? After finishing this lecture, we may be able to understand the reasons behind it. From the above examples, we can see that the above ground part of the Leaning Tower of Pisa building is intact, so the key issue lies underground. And for underground structures, it's easy for us to think of foundation soil and building foundations. So, which link went wrong? So we need to know the relevant knowledge of foundation soil and building foundations. In architecture engineering, the load-bearing component located at the bottom of the building, buried underground, and directly acting on the soil layer, is called the foundation. The soil layer beneath the foundation that supports the total load of the building is called the foundation soil, and the total load of the building is transmitted to foundation soil through the foundation. Foundation soil can be divided into two categories: natural foundation soil and artificial foundation soil. Natural foundation soil refers to a natural soil layer with sufficient bearing capacity, without the need for manual improvement or reinforcement. A foundation soil that can directly withstand building loads, rocks, crushed stones, sand and gravel, cohesive soil, and so on, can generally be used as natural foundation soil. Artificial foundation refers to the weak bearing capacity and the lack of sufficient stability of natural soil layers. The foundation soil that cannot meet the requirements for bearing the load of the upper building must be artificially reinforced to improve its bearing capacity and stability, such as silt and artificial fill. There are usually three main methods for manually reinforcing foundation soil: compaction, soil replacement, and pile driving. Let's look at the characteristics of these methods one by one. The first compaction method can be divided into three types: dynamic compaction, vibration compaction, and mechanical compaction. Dynamic compaction method, also known as strong compaction method or dynamic consolidation method. It uses a large track dynamic compactor to freely drop a heavy hammer weighing 8 to 30 tons from a height of 6 to 30 meters, strongly compact the soil to rapidly increase the bearing capacity and compression modulus of the foundation, forming a relatively uniform and dense foundation soil. Vibration compaction is placing vibrating machinery on the surface of a foundation soil for a certain period of time to vibrate, and using its excitation force to produce shear compaction in the soil, uniformly densify the soil within a certain depth to improve the mechanical properties of the foundation soil. Mechanical compaction refers to the use of the gravitational force of the rolling wheel by machinery to cause permanent deformation and compaction of the compacted layer. The soil replacement method involves excavating a certain range of soil from the foundation soil, replacing it with materials such as sand and stone, and compacting, vibrating it layer by layer. The foundation soil treatment method, based on the bearing layer as the foundation, is a traditional shallow foundation treatment method. When the load on the building is large, and the thickness of the soft soil layer and the foundation soil is over 5 m. The foundation cannot be buried in the soft soil layer when it is difficult or uneconomical to manually treat weak soil layers. Pile foundation soil are often used. The use of pile foundation can save foundation materials and reduce the amount of excavation and filling earthwork, improve the working conditions of workers, and shorten the construction period. Let's take a look at some typical examples of improper foundation and ground treatment. The Truncan barn experienced overall sliding due to foundation soil strength damage, which is the case with the Leaning Tower of Pisa that we saw earlier. Due to uneven foundation soil and soft soil layers, it tilted significantly. The Suzhou Pagoda has tilted due to uneven thickness of the tower foundation soil and incomplete design and construction of the tower pier foundation. From the above examples, we can see that improper treatment of foundation soil and building foundations can bring significant consequences. So it is crucial for building to handle the foundation soil and groundwork well. The requirements for foundation and groundwork in engineering mainly include the following 3 points. 1. The site of the building should first be selected in areas with high bearing capacity and uniform distribution, such as rock, gravel, and sandy soil. If the soil distribution of the foundation soil is uneven or poorly treated, it is highly likely to cause uneven settlement of the building, leading to wall cracking, building tilting, and even damage. 2. The foundation should have sufficient strength and durability. The foundation is an important load-bearing component of a building and a concealed project buried underground. It is susceptible to moisture and difficult to observe, maintain, reinforce, and replace. Therefore, in terms of construction forum, it must have sufficient strength and durability that is compatible with the upper structure. 3. Basic engineering should pay attention to economic effects. Basic engineering accounts for about 10% to 40% of the total construction cost. To reduce the total investment of the project, the first step is to lower the investment in basic engineering. Artificial foundation soil are more labor-intensive and material-intensive than natural foundation soil. So natural foundation soil should be selected as much as possible to reduce costs. When the location does not allow for selection, try to adopt appropriate foundation forms and construction schemes, source materials locally, and save transportation costs to save project investment. That's all for the overview of foundation soil and building foundations in this lecture. Thank you all.